Hello, my name is Muhammad Mustafa Sayi. I'm a mechanical engineer and I'm here to present you my 5th year X project, the two-wheel tractor. So it has been in partnership with Oggun CleBer. We've noticed a big problematic in Africa that small land farmers tend to have less mechanization than big land farmers. So to come up with a solution, we decided to manufacture a two-wheel tractor based on hydraulics. Why hydraulics? Because hydraulics is one of the most powerful technology available to human. Also, it gets zero turning, which basically means that you can use it with only one wheels or spin one wheels on one side and the other wheel on another side. Which is basically really important for the ladies with less strength than men in general. Also, the second aspect is it's pretty cheap and most of it are off-the-shelf parts, basically manufactured already here and ready to employ it. So if today your engine was broken, we can just provide you an engine which is way faster than having to go and open it and do another one or assemble another one at the same time. Also, everything has been welded, as you can see, in Senegal, which basically means that all of our welders can weld it wherever you are in your own country or on this continent of Africa.
This stuff?
Why not?
It's difficult.
It's not difficult.
Yeah.
You have the knowledge, man.
Nope.
The school provides you the knowledge, don't you?
Can, yes, but with the machine I can, but I don't have enough strength to just do what you do right now.
You do. Look at me. I'm not much bigger than you are.
Yeah, not bigger, but maybe more.
It's not a matter of bigger, it's a matter of... DAUST is an American school, an American English program school, where I've been able to learn a lot from the mechanical aspect. In matter of fact, I was in China for 4 years doing my bachelor degree, and when I came back, I was not able to get a higher education than this one. Most of the school are much French taught, and I wanted to have an English program orientation for myself, and DAUST was able to get really brilliant teachers and teach me a lot of mechanic stuff, just like statics, dynamics, even hydraulics, and this is the big proof of what I already learned in here. Easy. 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 Let me introduce you to our technology. First, the different components. First, we have a conventional combustion engine, an Honda very reliable engine, 390cc, providing enough power for our pump, which we'll come to it later. Second, as you can see, there is 2 hydraulic motors attached to each wheel for our zero-turn maneuverability. Each motor is as powerful as a Land Cruiser V8. People that already know cars know the reference I'm talking about. Next up, we have the coupler, which is directly connected to the pump. What does it mean? That engine, the combustion engine, will provide enough torque and speed at rotation for the pump to start working and pumping the oil through the pump and then the motor. That tank will basically get all the fluid that you need and will get sealed, as you can see, with a filter, which will be able to filtrate all of the oil and all of the impurities inside the oil. If only it was that easy.
comme cela. Hop. Hello. Ah merde. Les sœurs, ouais, c'est les sœurs. Moi la clé. La clé, la clé, la clé. Moi le petit, la mèche. Et le pire, il en reste 3 autres. Hein? J'ai dit, et le pire, il en reste 3 autres.
3 autres?
3 autres.
Hein?
Où est la mèche?
Elle est là.
J'ai dit, le pire, il en reste 3 autres.
Il en reste quoi?
3 autres.
Ah, les trous, n'est-ce pas?
Hein? What? Hey, hey. Hey. Oui. Ok, ok. Ok. Ça rentre?
Ouais.
Ok. Ça rentre, super. Ok. Voilà. Let's go.
You can turn it on.
Yeah. The water, the water. Excellent. Let's see. Where's the? Right now we're working on the chassis, so we had to make screw hole to save weight, basically. Hopefully you'll see more about it later. Yeah, it's perfect.
On parle de mécanisation, on parle là soit de fabrication du matériel, soit de l'entretien, de la maintenance de ce matériel. Donc c'est les principaux acteurs, il faut qu'ils soient impliqués. Et bien entendu, tous les services de l'État, comme l'ANCAR, pour la dissémination de ces technologies-là, et l'ISRA, puisque c'est des questions de recherche, parce qu'il faut adapter les technologies dans le nouvel environnement. Donc nous sommes en partenariat avec donc des universités américaines, notamment Michigan State University, c'est-à-dire l'université de Michigan State qui se trouve aux États-Unis, avec Kansas State University, qui est une université qui se trouve au Kansas aussi aux États-Unis, l'université de Illinois, c'est à Chicago, qui aussi participe dans le cadre de ce projet, qui permettent de fédérer vraiment des compétences pour lesquelles on aura besoin de leur input pour que les choses puissent avancer. Donc, il s'est trouvé qu'au Sénégal, nous avons le DAUST qui est là, qui est Dakar American University of Science and Technology. Déjà, ça offre une nouvelle perspective, parce que, qu'on le veuille ou non, avec la mécanisation, on va s'orienter vers ce qu'on appelle l'agriculture intelligente, le smart agriculture. Et quand on va parler d'agriculture intelligente, il va falloir compter avec les nouvelles formes d'énergie. Pourquoi pas faire, disons, profiter de la mécanisation de ces nouvelles formes d'énergie, le soleil. Tout le temps, on voit des tracteurs qui marchent, mais c'est au gasoil. Vous connaissez le gasoil, la crise actuelle. Bon, on ne sait jamais avec le gasoil. Mais pourquoi ne pas utiliser le soleil qui est là, qui nous appartient, qui appartient à tout le monde, qui est gratuit? Est-ce qu'on peut développer des moteurs qui nous permettent de travailler en toute indépendance? Donc, vous voyez donc, c'est des nouvelles technologies qui devraient venir améliorer ce que les producteurs sont en train de faire. Et donc, le premier point de départ, c'est de comprendre d'abord qu'est-ce que les producteurs sont en train de faire en termes de mécanisation, en cas pour améliorer leur système de production. Et sur cette base-là, on essaie d'améliorer. Et donc, nous utilisons tout ce dispositif de partenariat que nous avons avec les universités américaines dont je vous ai parlé et les partenaires sénégalais, sans oublier le secteur privé, parce que je vous ai parlé des artisans et tout ça qui doivent intervenir de manière significative, faire en sorte que cette technologie-là puisse introduire, mais de manière durable. C'est ça la durabilité. La durabilité, c'est que la technologie, que le travail que nous sommes en train de faire soit reproductible à l'infini. Il ne faudrait pas que dès que le projet se termine, on se dit au revoir et chacun... Non, non, non. Il faut qu'on travaille de manière à ce que même si le projet se termine, qu'on puisse continuer à faire ce travail-là, voilà, pour le bénéfice des producteurs.
We just earlier talked about by 2050, you need to double the production. How are we going to do it? We have to think of a disruptive technology. We cannot go on with business as usual. We have to find a way to change bend this curve very sharply upwards. Okay? And I'm not saying any one thing. It has to be a combination of approach. We have to really think out of the box how we're going to do this. Okay, so what have we learned about Senegalese agriculture? With that kind of background, soils are generally degraded and lack organic matter. In the peanut basin, agriculture is rain-fed, which you all know. Most farming operations are completed manually or by animal traction, mainly horses and donkeys. Crops are planted by a super eco seeder, which is the most popular seeder in this country. Animal manure is an important organic fertilizer because if there are animals here and the organic fertilizer is very important in this region. Senegal River Valley is a rice and vegetable production area with some mechanical traction, year-round production with irrigation. Okay. And the Nayes zone is exclusively horticultural crop production area. So that's what we have learned so far by our various interactions. So what's our approach to addressing mechanization issues in Senegal? Well, primary focus is on the peanut basin. That's something we mentioned because that's where the need is the greatest. Main crops of interest are maize and millet and perhaps sorghum as well. The approach we have taken is that we should look at technologies that tend to integrate plant and animal production. And what that means is that we are focusing on two technologies here. One is forage chopping, which actually creates feed for animals. So feeding animals and then looking at how can we apply manure in the field in a more effective and efficient manner by drilling them into the strips to have similar effect by less amount of manure applied per hectare. So those are the technologies that would help achieve some level of plant-animal crop production integration. The next one is, we talked about soil centigrated, and that is, we're going to focus on not just doing mechanization to do the conventional set of practices. We want to look at how can we now go into conservation agriculture in a sustainable way. So we are setting up experiments to look at how we can develop a system of tools, implements to practice sustainable agriculture, and we're going to learn quite a bit on that, and you will hear more about it from Dr. Fay as we go along. And then the way you can increase power or energy per hectare as an input is to go to some sort of a mechanical traction device. Keeping in mind, you have small farmers, you have medium-sized farmers, of course large size. Large farmers can already go and get four-wheel drive tractors, and they have. It's the medium size and the smallholder farmer is what you got to look at. So we are looking at introducing two-wheel mechanization technology to do farm operation. And we are looking at several different designs. Students at DAUST are developing a set of system which uses petrol power engine and hydrostatic transmission, which gives you immense flexibility. We have shipped a two-wheel tractor with mechanical transmission, which is probably sitting somewhere at the airport right now. Yes. And but hopefully, with the container or the crate arrived this morning by Turkish Airlines, and hopefully tomorrow they'll be opening the box and getting things out. So we're gonna put that to work, and we are also looking at developing an electric two-wheel drive tractor, which will be then powered by solar. It will be powered by battery is charged by solar power. So we're looking at a conventional technology, intermediate technology with hydrostatic, and then really far out cutting edge technology in two-wheel tractors. Okay, so this is the Tillmore two-wheel tractor. It's about 3.5 horsepower, light duty tractor, and we think if you don't do primary tillage, which we don't intend to do as a part of conservation ag, then it can be used for a variety of secondary operations such as ripping, planting, weed control, and such. So Dr. Demba is going to be working on that. At the same time, we'll be looking at comparing these different technologies, and folks will be working on that. But this is a new partnership. Tillmore is very active in Uganda and Kenya. So, and they are very interested in coming to Western Africa. So, again, our latest collaboration is with DAUST. They are developing the two-wheel tractor, which is almost ready, and hopefully next month we'll be taking it out into the field. It's advanced technology in terms of hydrostatic transmission. We don't know anywhere in the world there is a two-wheel drive tractor which is driven by hydrostatic transmissions. So that will be a first here. So, and of course, we are working with ASABE very closely, and the initiative, there's a new initiative. I'd be remiss if I didn't put in a plug for the AMAA that you see on your screen, that is Alliance for Modernizing African Agriculture. Okay, and this is a concept which is designed to leapfrog the natural evolution of technological development. And this is where we are looking at bringing all appropriate cutting-edge technologies to bear on agriculture in the continent of Africa, driven by one simple concept, that modernizing African agriculture will lead to a rapid development of agriculture, which will be the economic engine for the continent of Africa. In a way, it was in the US. So we are taking a business approach. So the tagline for this is making a business case for investment in modernizing African agriculture.
As a conclusion, I can say that the project has been pretty successful. 80% of the job has been already done. We just have to prepare for the controls and the final testing throughout the land, basically in Saint-Louis. That's where we decided to go for. The outlook of the project, we're still on it, and we're trying to manufacture many compatible elements and structure that be able to help the small and middle land farmers to go and work further based on mechanization and go away from our rudimental technology that we've been using since years and years of work. Thank you very much.